What problem does the proposed method RLHF aim to solve in the context of aligning large language models with human values?
The proposed method RLHF aims to solve the problem of aligning large language models, LLMs, with human values by using reinforcement learning from human feedback. RLHF gathers human judgments on model outputs to fine-tune the LLMs to produce more desirable and aligned outputs based on human preferences. This method addresses challenges such as unrepresentative data, unrealistic models of human decision-making, and insufficient modeling of human diversity in the context of training safe and ethical AI systems. By incorporating human feedback through RLHF, the aim is to bridge the gap between the capabilities of LLMs and the alignment of these models with human values. The method seeks to ensure that LLMs produce helpful and harmless outputs based on human judgments, thus enhancing the controllability and alignment of these models with human values.
Can you explain step by step how the proposed method of RLCHF works in training a reward model and fine-tuning the AI system?
The proposed method of reinforcement learning from collective human feedback, RLCHF, works by incorporating preference aggregation as an additional step into the RLHF pipeline. In a simple version of rankings-based RLHF, the process involves generating prompts X with corresponding sets of possible responses, Y, asking a jury J X, Y, of evaluators to provide individual rankings R_J, and then aggregating these rankings into a collective ranking R using an ordinal social welfare function F. This aggregated ranking is then used to train a common preference model Vero that produces numerical ratings R equals Vero XY. The next step in RLCHF involves using cardinal preference aggregation between steps 3 and 4. Here, individual preference models are trained to map pairs X, Y, and evaluator features F_I to predicted ratings R_I equals psi X F_I Y. A cardinal social welfare function W is then used to aggregate these individual ratings into one rating Vero XY equals W psi X F_1Y dots psi X F_NY, which is used to fine-tune the actual AI system via reinforcement learning. Overall, RLCHF introduces a collective decision-making step into the training process, either through ordinal or cardinal preference aggregation, to generate a collective ranking or rating that is used to guide the fine-tuning of the AI system. This method aims to leverage the wisdom of a group of evaluators to provide more robust and representative feedback for training the AI system, ultimately leading to more aligned and ethical AI systems.
What are the theoretical or practical benefits of using constitutional AI, CAI, as an alternate approach to RLHF in the paper?
The theoretical and practical benefits of using constitutional AI, CAI, as an alternate approach to reinforcement learning from human feedback, RLHF in the paper, include the explicit specification of principles to guide the LLM training process, the ability to align the LLM with these principles, and the consideration of diverse preferences in a principled manner. CAI allows for the creation of a constitution that outlines specific principles for the LLM to follow, providing a structured and principled approach to training AI systems. This ensures that the AI system is aligned with the values and preferences specified in the Constitution, leading to more ethical and safe AI development. Additionally, CAI addresses the challenges of aggregating diverse preferences by using a set of principles as a guide for feedback and fine-tuning, promoting fairness and inclusivity in the AI system's decision-making process. Furthermore, CAI introduces a method for generating artificial preference and instruction data based on the Constitution, allowing for model fine-tuning in a controlled and principled manner. Overall, CAI offers a systematic and structured approach to training AI systems, ensuring alignment with specified principles and promoting ethical and responsible AI development.
How is the human feedback collected in RLHF according to the paper?
The human feedback in reinforcement learning from human feedback, RLHF, is collected by first generating and evaluating a dataset of model outputs. In vanilla RLHF, humans are shown paired completions to prompts and asked to select their preferred output from each pair. Other variants of RLHF may require humans to rank or provide scores for groups of outputs. The next step involves fitting a parameterized reward model to the dataset of model outputs. This reward model is optimized to match the likelihoods of human preferences observed in the data. Finally, reinforcement learning is used to train a policy that maximizes rewards from the reward model. The human feedback is used to fine-tune the large language models, LLMs, to produce more desirable outputs based on human judgments. The paper also discusses alternate preference-based fine-tuning objectives, such as direct preference optimization (DPO) and Kahneman-Tversky optimization (KTO), which optimize model based on collected preference datasets in different ways.
What are some concerns raised in the paper about potential drawbacks of using social choice theory for addressing open problems in AI alignment?
Some concerns raised in the paper about potential drawbacks of using social choice theory for addressing open problems in AI alignment include the risk of strategic voting or feedback, where individuals may manipulate their feedback to influence the outcome in their favor. This could lead to inaccurate or biased feedback, undermining the effectiveness of the alignment process. Another concern is the violation of anonymity, where certain evaluators may have more influence or weight in the aggregation process, potentially favoring some stakeholders over others. This could lead to unfair outcomes and a lack of representation for all stakeholders. Additionally, the paper discusses the challenge of incorporating diverse and informal feedback into AI systems consistently, as different formats of feedback may lead to differently aligned systems, raising questions about the reliability and consistency of the alignment process. Furthermore, the paper highlights the complexity of navigating a multiplicity of AI systems, as creating multiple systems to cater to different groups may lead to division and conflict, especially if the systems have competing goals. This could result in fragmentation and inefficiency in the alignment process, potentially hindering the development of responsible AI systems.
Based on the proposed method in the paper, how should diverse individual input or feedback be incorporated into AI systems?
Diverse individual input or feedback should be incorporated into AI systems through a process called reinforcement learning from collective human feedback, RLCHF. This method involves introducing preference aggregation as an additional step in the RLHF pipeline. One approach is to aggregate individual rankings provided by a jury of evaluators into a collective ranking before training a common preference model. This method, termed RLCHF using aggregated rankings, ensures that diverse preferences are considered in the training process. Another approach is to aggregate individual preferences based on evaluator features using a cardinal social welfare function. This method, known as RLCHF using evaluator features and aggregated ratings, aggregates ratings from multiple evaluators to produce a common rating for fine-tuning the AI system. By incorporating social choice methods like preference aggregation, RLCHF allows for the integration of diverse individual input or feedback in a consistent and effective manner, ensuring that the AI system aligns with a broader range of preferences and values.